And welcome everyone. Thank you for taking your time to join us for today's webinar. So my name is Jason. I'm based in Melbourne, Australia. I'm a health economist and a sexual health physician, and one of the conveners of the Health Preference Research Special Interest Group for IHEA, together with Fern Terrace-Pressholz, Matt Quaife, and Yan Mong. And certainly please check out our group on the website, the IHEA website, if you'd like to learn more about health preference research. So health preference research, for those who are not in this area as yet, is dedicated to understanding the value of health and health-related goods and services. And the mantra in health preference research is choice defines value. So with a better understanding of what people want, providers, regulators, and policymakers can better meet people's needs. For this, research commonly design and conduct studies such as discrete choice experiments, which is a survey method that quantitatively measures what people want or value. So for today, we're very fortunate to have Associate Professor Richard Norman to share about how DCEs can be used to value health for cost-utility analysis. So Richard is no stranger to many of us. So he's a health economist based at Curtin University in Perth, Australia. And his research focuses on economic valuations of healthcare, measurement and valuation of quality of life, DCEs, and econometric analysis of large panel data sets. So as Di mentioned, the talk will run for about 30 minutes, and we want to have a significant time for your discussion and your questions. So I'll be monitoring the chat box throughout Richard's talk, and we will present the questions to him at the end of his talk. So the floor is yours, Richard.
Great. Thank you so much, Jason. And obviously, thank you to IHEA and to the Special Interest Group for the opportunity to talk to you all today. I'll just share my slides. So yeah, as Jason said, I'm Richard Norman. I'm a health economist based in Western Australia at Curtin University, and I'd like to acknowledge that that today I'm dialing in from the lands of the Whadjuk Noongar people, and would like to acknowledge their leaders, past, present, and emerging as well. So this topic brings together a couple of key threads in IHEA's research program. So for those of us fortunate enough to attend the plenary in Cape Town recently, there were a large number of studies around discrete choice experiments, and there were similarly a lot of presentations around economic evaluation, specifically cost utility analysis. But there weren't necessarily that many bringing the two things together, and it's an intersection which is rapidly growing, and I think that it's extremely valuable for many of us who work at that intersection of method and policy. So I understand that these webinars are intended for people both with significant prior knowledge, but also no prior knowledge. So I'm going to try to step through the topic incrementally. First, introducing DCEs generally, and describing the quality framework, both of which are things which many of you will be familiar with anyway. I'll talk a little bit around historical approaches to valuing health for cost utility analysis, mainly through quality adjusted life year construction. I'll try to spruik the advantages of discrete choice experiments generally, and talk about the unique challenges of conducting DCEs to value health for the purposes of cost utility analysis. I'll give a couple of examples from existing studies, talk a little bit around things like data quality, and then conclude with some ongoing uncertainties and future research directions, hopefully to inspire people to try to solve some of the problems which we in the field have really been grappling with over recent years. Okay, so for those of you who haven't dealt much with discrete choice experiments, they are a stated preference survey approach. And in the most general sense, what they are they're a question or series of questions where respondents are asked to consider a hypothetical situation, and they're asked to make a decision between competing options. And they have a really, really long history across a number of areas of public decision making. And the classic text goes back to 1927 and Thurstone, who was attempting to weight the importance of a series of contemporary crimes. And that's a very interesting and eye-opening read for those of you whose library gives permission to access it. Discrete choice experiments now are widely used across a number of areas of economics. So I think that they took off earliest in areas such as transport and agriculture and marketing. And over time, they've become increasingly widely used in health as well. On the right-hand side of the slide, I've given a stylized example of a choice set, which I took from some work by Esther Becker-Grow, who presents a travel example where an individual is presented with two options, a car and a train, each of which can be defined by a series of attributes, which you can see on the left-hand side. And those attributes can each take one of a set of levels. So you can see, for instance, the car can be a 20-minute trip, the train can be a 25-minute trip, and so on. I think, as with any sub area of health economics, there's a significant amount of jargon which the uninitiated have to deal with. So I've just put some nomenclature down in the bottom right hand corner of the slide, just to explain that we often use terms reasonably interchangeably. So choice sets and choice tasks are often used interchangeably. The options in a choice set can be called alternatives as well. The attributes can often be termed dimensions, and each attribute is set at a particular level. I'm saying that partly to help you not get confused between terms, but also to give myself an out, because I can be quite careless in terms of using the terms interchangeably, and I don't want to accidentally mislead. So I said that the uptake of discrete choice experiments in health economics has been later than in other fields, and you can see the figure on the right, which is from a recent study from a team of Chinese authors, that the uptake has been significant over the past 2 decades, from a reasonably low baseline in the 90s and the early 2000s to a significant number of discrete choice experiment studies in the field of health. I think that it's unsurprising that there's been considerable uptake, and indeed I think it's been somewhat surprising that it took so long, because we all know that health is an area where the free market doesn't apply in most settings. Goods and services in health are not often traded in the microeconomics 101 type setting, meaning that we don't always observe values for things in a kind of a market solution. So to get those values, we often revert. Well, it makes sense to revert to a stated preference type approach rather than a revealed preference type approach. And one thing I would say is that discrete choice experiments are an extremely flexible tool which can be used in a variety of different ways. So they can be used to explore preferences, they can predict uptake, they can identify preference heterogeneity, and so on. So I think that if you're interested in preferences and in how people make decisions and in how people ascribe value to components of products, DCEs are a viable solution for those kinds of questions. A couple of advantages of discrete choice experiments generally, before I dig into the health state valuation literature. They're easy to administer online, which is extremely handy. So increasingly, discrete choice experiments are administered electronically. They can be sent via a web link, and typically speaking, The evidence suggests that the results we get from a pen and paper or an interviewer discrete choice experiment are largely comparable with the results we get if we administer them online, which is terrific. And this has a number of advantages. First, it means we can have larger sample sizes than through more labor-intensive modalities, which is great. And additionally, we can overcome the geographical logistic problems and get a really broad geographical spread. So when we run surveys, we can make a strong claim about the geographical generalizability of our results. I also think that unlike some other stated preference surveys, such as certain flavors of contingent valuation and things like time trade-off, discrete choice experiments, if designed sensibly, can be reasonably robust against poor quality data. So if people enter a discrete choice experiment that's been designed adequately and they answer without much thought, without any thought, the impact is to add noise to the model parameters rather than to introduce systematic bias into our results. And that's a really big strength. That's not a reason to try to ignore data quality, and I'll talk about that a bit later. But I think that that's a real strength which can allow DCEs to be administered through the web. Okay, I'm going to try to get through the slide reasonably quickly because I know most of you will be familiar with the concept of a quality adjusted life year. But there's one key point I want to take from this slide for those of you who are already familiar with the QALY. So in cost utility analysis, we know that the value of a healthcare intervention or the value of a profile of health over time is a product of some measure of quality of life, which is on the vertical axis here, and duration, which is on the horizontal axis. Specifically, the QALY model typically applied assumes that you simply multiply time by some measure of quality of life, which is anchored on a 0 to 1 scale. And that yields a QALY, which can then be used to compare a trajectory of health over time with and without a particular healthcare intervention. But what's important here is that as time tends to 0, the value of the health profile also tends to 0. So for a high quality health but duration 0, that's exactly the same value as poor quality health and time of 0, because either way you're dead. So we need to capture this multiplicative nature of that interaction between quality of life and duration, and that need to capture multiplicative. I can never say that word. This kind of multiplicative nature informs how we design the task and how we analyze the task as well, and I'll cover that as we proceed. So just to give a sense of the comparator here, when the Euroqual group, who are the primary developers of quality of life instruments for use in cost utility analysis, sought to value EQ5D health states, their focus is historically been on the time trade-off. And in the time trade-off, when you can see a picture of it on the right, individuals are asked to trade off between 2 lives. So life A is full health for 10 years, and life B is some health state that you're trying to value for 10 years. And in this question, the expectation is that the individual would pick option A, and then iteratively, the amount of time being offered in full health between 0 and 10 years until the individual reaches that point of indifference. And where they're indifferent tells us something about how severe the health state in blue that we're trying to value is. that's quite a challenging task, and involves a series of questions to get to a single valuation for a single health state, something which isn't true in the DCE. So in some sense, it is a cognitively easier task, and I'll present an example or two of what I mean in coming slides. Okay, so one of the issues with DCE for valuing health for use in cost utility analysis is that can mean different things to different people. So I want to present three different formats of DCE which are often used in the literature, each with strengths and weaknesses. The first one on this slide is called a DCE with duration, and in the literature it's often called DCE TTO. And the reason it's called a DCE TTO is because you're asking people to consider two health states which consist of both a health state and a duration. So it to some degree mimics what a TTO looks like. And you can see the stylized picture on the bottom of the slide, and you can see that attribute 5 is time. This is probably the most commonly used DCE for valuing health. And the reason why it's used widely is because it has some attractive features, particularly that it directly captures the trade-off between time and quality of life, which is required for the QALY framework. So we need to know for the QALY framework how much time people are willing to sacrifice to move between different health states. And the DCE TTO asks exactly that question. However, one problem with the DCE TTO is that it puts assumptions on how people answer the DCE that are implicit in the QALY framework, but aren't necessarily true. So it assumes, in the way it's typically analysed, that people treat quality of life and length of life or duration multiplicatively. But empirical work suggests that that's not necessarily so. So some work coming out of the Netherlands by Marcel Jonker from last year suggested that many people look at this choice task and actually treat quality of life and length of life additively or in some other relationship, and that leads to an element of bias in the results you get out of the DCE. An alternative approach is a DCE with DED. And this is a simpler task. So rather than present two competing health states with durations, you simply present a single health state. So in this case, health state A, which has a number of characteristics, and you ask the respondent to directly state if health is better or worse than being dead. And one of the nice characteristics of this kind of approach is that when you construct your QALY for different kinds of interventions, because you've asked people whether something is better or worse than dead, you know whether the mean person considers it to be a positive utility score or a negative utility score, and that's really valuable. And you see it much more directly here than you do with the DCE TTO or the DCE with duration. This hasn't been taken up massively in the literature, and I think that there are probably two reasons why that's the case. The first is that the task is extremely confronting. So in the DCE TTO, if I can just go back to the previous slide, you are asking people to consider dead because the time offered in health state A and health state B will typically be different. In the DCE with dead, you're asking the respondent to consider dead immediately. So it's not just delaying dead or bringing death forward. It's saying dead today or this health state. It's quite a confronting task, and I think there'll be portions of the population who will be challenged by that kind of thought process, and obviously there's an ethical issue around asking people questions that are confronting, but there's also an issue in terms of the quality of data that we get out of that kind of approach. I also think that the DCE dead may struggle to work well when scoring mild health states. So if health state A is very benign, then basically nobody will prefer dead to health state A, and we won't get a clear measure of where on that 0 to 1 scale the health state is likely to lie. Okay, the third option is a latent scale DCE with some external anchor, which could be anything. So here, rather than ask people to trade off directly between quality of life and length of life, we simply present two health states, which are described by aspects of health like pain or like mental health or mobility or whatever it might be, and we simply ask which of them is better. That's a much easier task for a respondent to answer because they're not being asked to make that additional trade-off with time. But the results you get from this kind of experiment aren't easily anchored on that 0 to 1 scale, which we then need for quality construction. And what's been done elsewhere in the literature is to use some kind of external anchor to rescale the results from this kind of latent DCE onto that 0 to 1 scale. And that can be something like a time trade-off, or it can be interview work trying to identify where that dead point lies. So which health states are better than dead and which health states are worse than being dead. And the limit of it is obviously that although we might be comfortable with the choice task and people might like it, the results we get out of it are reliant on the anchor being correct, and that's obviously uncertain. Again, to drill down on that point once more, this is an example which is actually used by the Euroqual group. So you may recognise the EQ5D health states on the right hand side. It's a simple task: which is better, state A or state B? And you can see there's no duration there at all. Okay, so I've talked through some of the possible ways of asking these choice tasks, and now I want to present a couple of slides giving you some trends in the health state evaluation DCE literature, just to give you a sense of how people in the field are conducting these kinds of studies. And I've taken some data from a review done by Brendan Mulhern from 4 years ago, reporting on the characteristics of these DCE studies. And there's a couple of things I want to pull out both on this slide and the next one. So you can see that the number of health attributes typically lies in that 5 to 6 range. There are some with more, but if you have an instrument where if you're provided with an instrument with say 20 attributes, then the DCE approach might be challenging to ask those kinds of questions in a general population sample. What I would say is that there is pretty good evidence from cancer, a series of projects that I'm involved in, showing that if you constrain the DCE in quite specific ways, then people seem able to respond to DCEs with 10 or 11 health attributes in a way that appears to provide a high quality answers. So I don't think there's an upper limit, but as you increase the number of attributes that you present in your DCE, you have to think more and more about how to make the task amenable to people. In terms of anchoring, which relates to the 3 DCE formats I just talked about, there doesn't seem to be much of a consensus, at least up until 2019. And I think this pattern probably is true up until 2023 as well. So the DCE with duration is the modal winner with the most studies, but there are a significant number of other studies which either don't use anchoring or anchor using some external data, and basically none that present a DCE with dead, which I think is interesting. And the final point is just that, typically speaking, these choice tasks are difficult, and therefore most research teams focus on presenting DCEs as pairs. So by that I mean health state A versus health state B, rather than health state A versus B versus C, or A versus B versus C versus D, or so on. couple of other things to flag before I move on. Large sample sizes are becoming the norm. So you look at the sample sizes that are reported in Brendan's work, and the majority have samples of over 1,000, and that reflects the relatively low cost of collecting data for this kind of survey. You can produce large sample sizes quickly, and that gives you the ability to explore heterogeneity of preferences around health and subgroup analysis, and to get nice precise estimates on the things that you're trying to measure, which is a real bonus for the field. In terms of the number of choice sets each respondent is answering, it seems as if the range of 10 to 15 choice sets people are reasonably comfortable managing. I think the study that presented 108 choice tasks per respondent might have been pushing it a bit, but I certainly, in my experience and in the experience of most studies that I've seen conducted elsewhere, 10 to 15 is probably typical, and that doesn't typically cause significant difficulty for respondents. And finally, I just want to reiterate the point that online administration was already the most common approach to DCE administration up to 2019, and that's a trend which will have, if anything, increased in the years since this review took place. Okay, I talked earlier about quality of life and length of life needing to be multiplicative, and that requires quite a specific parameterization of the utility function when we analyze our DCE data. And there have been a couple of studies from around about 10 years ago which talked about how to do this, but they were neatly it was neatly summarized in the study by Nick Bansbach et al. From 2012, who asserted that we can tweak our regression model to capture that interrelation between quality of life and length of life in the following way. So we have a main effect term on duration, so the number of years in a particular health state. And then rather than have main effects on the different aspects of quality of life, rather we have them on interaction terms between quality of life and duration. And you can think of this as taking away a proportion of the value of each year of life. This is quite an unusual econometric setup for DCE data, but is one that has been used widely in the literature now, and there are some ongoing challenges around it, but it seems to have been broadly accepted as a reasonable way of capturing preferences around quality of life. Okay, one of the big stumbling blocks for people entering the world of DCE is uncertainty about how to build their experimental design. So for those not familiar with DCEs, what I mean here by experimental design is the systematic way in which we identify the choice sets that are presented to people in the DCE. So for a particular health instrument, there might be 100,000 possible health states, and then because each health state can be paired with each other health state, you then have millions and millions of potential choice sets. And how you pick which ones actually asked to people in a way which maximizes design efficiency and gives you unbiased estimates is quite challenging. And I would argue that the appropriate experimental design for this kind of DCE actually follows a lot of the same rules that apply to DCEs generally. This presentation is not a presentation around experimental design, and if it was, I certainly wouldn't be the person to be presenting in it. But there are a number of excellent texts out there to give guidance on experimental design. So there's the good ISPOR guidelines by Reed Johnson from a decade ago. And then there are a number of texts out there providing step-by-step guides to building experimental design using things like generator-based approaches by Street and Burgess, or the Engine type approaches, which have become increasingly widely used in the field as well. So well, one of the things I want to point out is that within the context of a DCE, the efficiency of a design makes an assumption about the betas that you're actually trying to capture. So having an experimental design which is efficient for 0 priors, so assuming that answers are basically at random, doesn't necessarily mean that design is efficient in the real world, where people do have preferences for different components of the study. So I think that one thing I've observed over recent years is there is an increasing trend in DCEs more generally, not just in this area, but more generally, to use informative priors based on pilot work. So you can run a small pilot, produce some results, and then use those results to build a better design for your main study. And I think that that's typically speaking good practice, which you should be considering. And given the cost of data is reasonably low, the cost of doing that is also therefore relatively low. We're not, unless you're talking about patient-specific discrete choice experiments, you're not really limited in how many people you can ask a DCE of. So collecting that prior data is I think a good strategic decision to get good results out of your DCE. On a related point, one of the things that struck me moving into DCEs over the last 10 years or so is, compared to other surveys, the speed at which data can be collected can actually, it's terrific how fast we can get data, but it can also be quite scary because if you have made a mistake in your experimental design, you may not spot it until you've already got 500 respondents or 1,000 respondents, at which point you've spent quite a lot of money and quite a lot of effort collecting data. And I think that what that speaks to is the importance of two things. So simulating data to make sure that the design is able to retrieve sensible coefficients out of your model, and also conducting soft launches before main data collection. So opening up to, say, 100 respondents, checking the data looks reasonable, and then launching the survey again to collect the remainder of your data. Okay, so I want to spend a slide talking about data quality, and I've shamelessly stolen this graphic from COVID. This graphic was about how a multi-pronged strategy can protect you most from COVID, and I've adapted it to make it about data quality in DCEs. I think that using online methods to collect DCE data does leave surveys susceptible to poor quality data. So people not being watched, not having to justify their responses, people or even bots working in an online environment can mean that some of your data can be poor quality. And I think, unfortunately, there's not a single solution to maximizing data quality. So I think the best approach is to use a series of methods, all of which are imperfect, but cumulatively will lead you with very high quality data, hopefully. And I'll just step through some of those now. So I think that the way we recruit our sample through a reputable panel is really important. So if you're conducting a survey in the general population, you want to engage not necessarily the cheapest panel of survey respondents, but one which has a real system for identifying poor quality data from previous surveys and excluding them. So you're left with people who have shown diligence and dedication in completing surveys previously. I think that the survey itself needs to be rigorously tested before it goes to field. So that there's a reasonable literature in this space conducting things like think aloud surveys, where people are asked to complete a DCE, talking through why they're making decisions at each point, not to provide data for the final analysis, but to make sure that the typical person is able to understand what we're actually asking them. And we've expressed what we're trying to get at in the DCE in a way that's interpretable, and that's not always the case. I think that there is considerable scope to exclude people based on a variety of additional tasks that you can add to a DCE. So after you've asked your choice sets, you can repeat one of the choice tasks potentially. And if someone answers A the first time they see a choice task and B the second time they see a choice task, that doesn't necessarily mean that they're poor quality data, but it is a potential flag. And I think that there is good reason for exploring whether excluding those kinds of people changes your results. And if it does change your results, then you have a decision to make about whether someone who fails that repeat task, but kind of validity check, should be included or not. You can do the same thing with dominant pairs, so giving a choice task where A is clearly better than B, for instance, and also by looking at free text data and seeing if people are giving free text that makes sense and is answering the question that we're actually posing. So one of the strategies I saw recently, which I thought was really clever, was in your online survey to have a question which where the text and the box in which you put the answer is exactly the same color as the background. So the human eye will miss it completely, but a bot completing the task will see it and will complete it anyway. To me, that's a terrific way of potentially excluding computer program bots who are completing surveys with the hope of being paid for what is quite low quality data. I think we can similarly exclude based on response patterns. So if we collect timestamp data, we can see how long people take to complete tasks, and we can also identify people who answer A on everything, for instance. And again, going through a DCE extremely quickly can be an indication of poor quality data, but it can also be an indication that someone just has very definite views and know exactly what they want, and therefore is not poor quality data. So that's why I think this kind of Swiss cheese model of data quality is correct. It's one mechanism for excluding poor quality data, but it's not a golden bullet, if you will. And finally, I think once we have our data, there are a variety of things we can do in our analysis to identify poor data. So there is a growing literature using something called junk class models, where you run a latent class analysis on your data, but force one of the classes to have basically zero coefficients on everything. And as people get allocated to that class, basically you're drawing out the people who answered questions randomly and would therefore produce zero coefficients on everything. And your remaining classes tell us something about the people who are giving real data. And I think that's a really powerful approach to maximizing the quality of your data as well. Okay. I appreciate we're running a little behind schedule, so I'll try to get through an example quickly and then conclude. Analysis of this kind of DCE data typically follows a lot of the patterns that we see elsewhere in the DCE literature. So the conditional logic remains the workhorse of DCE analysis. It's historically been very easy to run, and provides mean estimates of preferences in a way which are easily interpretable. But as has been pointed out numerous times across the literature, it includes a series of assumptions which are unlikely to be realistic. I also think that the more advanced models, which model the heterogeneity across respondents, typically improve model fit significantly, and there's a number of flavors to this kind of heterogeneity modeling, things like mixed logits and latent class analysis. But I would say, as someone who uses these utility weights in economic evaluation, I think that we have to be a little bit careful about being a slave to model fit. We have to know why we want to know something about heterogeneity. If in the end we're purely using the mean effects, and we're basically throwing away the heterogeneity, are we definitely picking up a better model? I'm not convinced that that's always true. I've got two examples here, but I'll just walk through the first one due to time before concluding. This is from a cancer-specific quality of life instrument by Ravicki et al. And for those of you who work in the cancer space, this is based on the EORTC QLQ C30. We have a utility instrument which is derived from that, similar to how the SF60 is derived from the SF36. And you can see that this is a DCE with duration. We have a full health state and time in that health state at the bottom of the DCE. And you'll see here that we do have a lot of dimensions, and that's driven by the factor analysis, which basically boiled down the QLQ-C30 into something which could be a utility instrument. So what we did here is we imposed a degree of overlap. So you'll notice that the dimensions in white are the same between health state A and health state B. So people are not having to trade off over every possible dimension in the DCE. And we also color coded the choice task to help respondents see where health state A and health state B are different. A couple of interesting patterns I want to report just before I conclude. This is timestamp data allowing us to plot the distribution of speed through the 16 choice tasks that each person answered in this particular experiment. And what I've done here is I've presented the 10th percentile, the 25th percentile, the median, the 75th percentile, and 90th percentile. And you can see that all the lines drop over time. So people get faster as they go through the task, which could either be a learning effect or it can be a boredom effect. And the two things are quite difficult to disentangle. What you can do as a researcher is you can explore whether removing the fastest 5% of data or the fastest 10% of data actually matters. And if it doesn't matter, then the question becomes moot. And if it does matter, then the question is, how fast is too fast? One question I'm often faced with is this how fast is too fast question. So what we did in this American data, which is what we're talking about, is we broke the sample into 10 even-sized groups based on their speed. So we had about 2,300 respondents. So each decile had about 230 people. And we re-estimated the basic conditional logit model in each of those 10 deciles. So completely compartmentalized it and looked at the fastest 230, the next fastest 230, and so on. And what we looked at was the pseudo R-squared, so the model fit across the deciles, and also the number of statistically significant coefficients out of a possible 31. And what you can see is that there's a really significant pattern for the very fastest decile. So the R-squared is low and the number of statistically significant coefficients is also very low, suggesting that a significant proportion of the people who fall into that fastest decile are answering reasonably thoughtlessly or at random. But then above that, the pattern is a bit messier, and that there isn't a clear trend, in my opinion, once you go beyond that first decile. So this isn't perfect data, but I would suggest that probably when you enter the second and third and fourth decile, you're getting reasonably good quality data. So that does give us a handle on roughly what proportion of our sample are providing poor or good quality data. Okay, because of time, I won't linger on this second example, but the slides will be made available to you through the website, and I'm happy to talk through the study that I won't be talking about today by email or any other mechanism later. I want to conclude just by talking through a couple of uncertainties in future directions in the field. So one of the key things is around imposing the quality framework on our DCE data. And one of the key things that's built into the quality framework is linearity of utility with respect to time. So 10 years in a health state is twice as good as 5 years in a health state. But a number of papers have shown this isn't how people actually answer. So as with pretty much every good we ever see in economics, there's diminishing marginal utility, and certainly time appears to fall into that category as well. And a couple of studies from 5 years ago have presented methods for explicitly modeling and controlling for that diminishing marginal utility of time. This is a really growing area in the field. It's not widely done yet, but as time goes on, I think it's potentially something that might be integrated more broadly into our methods. In terms of data quality from online surveys, I've presented a couple of ways in which we can maximize the quality of our data. I've presented a few tips and tricks in this presentation, but I think there is a need to it's almost like an arms race between the bots and the researchers, and we have to constantly be adapting our methods to identify and remove data that comes from people who are not taking the task seriously, but also bots and ChatGPT driven respondents as well. And finally, I would say that I've been talking generally about valuation in general population samples, but I do think that valuation in specific groups in our community, so children or the elderly or groups with specific conditions, can pose unique difficulties around how we ask the task, how we frame the task, how we analyze the task, and how we report it as well. And I think there's a tension here because we want our tasks to be interpretable to all of these subpopulations. But because ultimately the results feed into QALYs, and we want policymakers to have confidence that a QALY estimated in one way is similar to a QALY estimated in another, we also want our underlying valuation techniques to be comparable as well, and that there is this tension there between the two things, which I think is unanswerable and ongoing, but we should all be aware of it. And that's everything. Apologies for overrunning. I think we have a little bit of time for questions now. So I'll hand back to you, Jason.
Thanks, Richard. That was brilliant. And thanks also for your discussion around data quality. I think that was some very useful tips for us to think about. We have some very good questions that's popped up in the chat. So I'll just, we've got about 5 of them and about 10 minutes before the end of the webinar. So the first one is the issue you raised about the confronting nature of the dead alternative. So Fern was mentioning it seems that 2 options plus a dead opt-out might balance the benefits of having the dead, but maybe more palatable, less confronting. What do you think about that?
Yeah, I think that's a great point, and that was actually the second example that my poor timekeeping meant I couldn't go through in detail. It's absolutely doable. You can treat dead as an opt-out. The challenge with that is that if you have duration and dead in an experiment, then you have multiple ways of anchoring the scores on a 0 to 1 scale. And the question then is, if one experiment is giving you 2 very different scales, which do you recommend? And that's, the quality framework says they should be the same, but they're not the same. So it reveals a problem with the DCE duration in terms of predicting dead that we don't otherwise see. So yes, it's a really good suggestion, Fern, and something we've done, but it poses additional problems doing it that way.
Great. Another question from Jade was around, is there a way to integrate the concept of risk aversion into DCEs to assess the individual's willingness to accept or avoid risk?
Yeah, it's a really good question again. Obviously, in the way that health states were valued historically, there was the time trade-off camp and there was the standard gamble camp, and both were attempting to capture the same thing, but in either using risk as the numeraire or using time as the numeraire. There's absolutely no reason why you couldn't use risk as the numeraire in a DCE. There are so many papers that I probably missed obvious ones. I can't think of many that have used that approach. I don't think there's a clear reason why not. So yeah, look, I think it's a really interesting possible area, and I'd be keen to see whether the patterns we see comparing time trade-off and standard gamble translate over to DCEs with risk versus DCEs with time.
Yep, great. Another question from Fern was, I guess, the question about throwing out data. So you mentioned, if people fail the internal validity tests, can you reflect on the risk of throwing out the data that might actually be real indecision?
Yeah, I'm always really hesitant to I always err on the side of not throwing out data. People answer questions in ways which we may not foresee, and it's often you need to be certain that the data are poor quality to throw it out. So in the presentation, I hedged my bets a little bit and said, what we should be doing is we should be assessing whether exclusion of particular data based on decision rules affects the result. And if it doesn't, then it doesn't matter. But then I skipped over what happens if it does matter. And that's a really hard normative judgment that I don't have a clear solution to. I think that seeing papers which exclude data in that way, you want to see the result with and without, so you can make the reader can make their own decision. But yeah, I think it's really hard to come up with firm rules as to what should be excluded and what shouldn't.
Yep, that's good. And Olawale is just asked an application question. So can DCEs also be applied to determining preferences for payment mechanisms to service providers? So capitation and fee for service?
So yes, they can. They can. I guess the question is, who are we asking? So you can get general population views around different payment mechanisms, and you could also ask clinicians about their preferences as well. And there are a number of studies which do exactly that. I think that answering a slightly different question, I think that studies which consider the same topic from both sides and see how the preferences of consumers and providers are reconciled is a really interesting area of DCE work, which I think we should be doing more of. Understanding where the two groups agree and where they disagree really helps frame future system design questions, which I think is really important.
Yep, totally agree. Now, Christopher has a question around how do we incorporate social determinants of health into DCE models to make the cost utility analyses more nuanced?
Yeah. Okay. So I guess there's a few answers, and I'm not sure exactly what question is being asked. So I'll ramble, and hopefully I get to the question that Christopher is asking. So there are so the examples that I presented have been quite narrow in terms of focusing on health exclusively. And there is a growing literature around broader well-being constructs and how they can be valued to build kind of an extended quality. But my hunch is that that's not what Christopher's getting at. I think that Jason, would it be okay to ask Christopher to come online and maybe expand on the question?
Yeah, for sure. Christopher, if you want to unmute yourself. Or if not, we can carry the conversation. Perhaps he can email you.
Perfect. Yeah, that sounds great. Yeah.
Okay. Oh yeah, in fact, he's asked me for my email. Oh yeah, someone.
This is Fern. Is it about market segmentation?
Sorry, in terms of the social determinants of health, Fran, is that what you mean?
Yes. So I think it might, I'm wondering, and of course, I can't speak for Christopher. I'm wondering if it's about looking at differential, being able to segment markets and address it, because his question seemed to go beyond estimating utilities. And okay, I think that, yeah, go ahead.
Oh, sorry.
I mean, DCEs are very much suited for market segmentation.
Absolutely, there, yes. So I think that maybe not so much in the health utility space, but in terms of preferences for health goods and services, the kind of latent class type approaches are extremely powerful, both in terms of explanatory power for how people are responding, but also importantly for giving data to policymakers in a way which gives them a way forward in terms of putting in policy that works across the population. So my personal view is that of the two approaches for looking at heterogeneity, so that I talked about, so mixed logit versus latent class, historically I've run a lot of mixed logits, and I think they're useful. But latent class says, you know, if you put in place a fee-for-service model for this particular good, then 20% of people will not engage. Now that's a silly example, but being able to identify the groups who are really strongly in favor of a particular configuration or particularly against is powerful information which can help policymakers make better choices.
Yep, perfect. And we're right on time, actually. So in fact, thanks everyone again for your attendance. Some of you are heading off to dinner, others are maybe starting your day off. So thank you once again, Richard, for your fantastic talk. And if people want to follow up with Richard, I think you can find him if you Google him and his email, I'm sure you'll find him. Or similarly, if you write to me, I'm happy to pass on anything to Richard. I'll just pop my email into the chat box. All right. Thanks again. Have a wonderful day.
Right. Thank you, Jason. Thanks, everybody.
Thank you.